Hello students, welcome to chemistry class. This is Chemistry Demystified with EB Christian. In our last class, we looked at some aspect of the periodic table. Today we're going to look at families of elements, and then this is the part one of it because it's of two parts. The groups are four groups, so I have to divide them into two parts. So in this video we are looking at the first part. Let's look at introduction. Introduction. Elements in the vertical column of the periodic table are called group. Elements in the same group of the periodic table behave in a similar way because they have same valence electrons. Though there is a gradual change in the properties of the elements as you move down the group. This change is due to atomic number differences and is called group trend. In this video, we shall begin looking at the various groups. Okay, so in the periodic table here, we have the group 1 elements and the group 2 elements. We have the group 3, group 4, group 5, group 6, group 7, and finally what? Group 8. We shall be giving attention to group 1, group 2, and group 3 in this video. Then in the next class, we shall be looking at the remaining groups. Now let's go to group 1. Group 1 elements are otherwise called alkali metal. Okay, good. Now these group 1 elements are univalent as they give out their one valence electron and become positively charged. They are good conductor of electricity and are very electropositive in nature. Examples include lithium, sodium, potassium, rubidium, calcium, and as well francium. Now this is, as you can see, this reaction, lithium. When lithium gives out its one electron here, E minus represents electron, okay? When it gives out its one electron, it becomes positively charged, okay? Good. And when sodium gives out its one electron, it becomes also positively charged. Now, when potassium also gives out its one electron, it becomes positively charged. If you observe that, we see all of them are single positive because they give out one electron. Good. Now, they readily react with cold water to liberate hydrogen while alkali is formed. So as you can see in this reaction, when sodium reacts with water, it gives you sodium hydroxide, which is an alkali, and then hydrogen gas is liberated. Same reaction is observed with potassium. When it reacts with water, it gives you potassium hydroxide, while hydrogen gas is liberated. Okay, good. And on heating, their nitrates do not readily decompose. Rather, they liberate oxygen. So if you heat sodium trioxonitrate 5, it gives you sodium nitrates and then oxygen is liberated. Okay, so it does not readily decompose easily. Now, same reaction is observed with potassium because they are all in group 1. Let's look at group 2 elements. Group 2 elements are otherwise called alkaline earth metal. They are actually divalent, and then because why? They give out two valence electrons and become positively charged. They are actually a conductor of electricity and are more electropositive than group 3 but less positive as compared to what group 1. Okay, the examples of group 2 elements include beryllium, magnesium, calcium, strontium, barium, indium, as well as what radium. You can see in this reaction when magnesium atom gives out its two electrons, it becomes magnesium ion, which is positively charged with two electrons, two atoms, okay, two ions, okay, good. Now, same reaction is experienced with calcium because in group 2, when it gives out its two electrons, it becomes calcium ion, which is positively charged. Calcium and magnesium, respectively, react with cold water and steam to liberate hydrogen, while hydroxide and oxide are formed respectively. So as you can see in this reaction, when calcium reacts with water, it gives you calcium hydroxide and hydrogen gas is liberated. Now, when magnesium reacts with water, with steam rather, it gives you magnesium oxide and hydrogen gas is what? Liberated. Interestingly, on heating, their nitrates readily decompose, forming brown nitrogen 4 oxide, oxygen, and oxide. So if you now subject calcium trioxonitrate 5 salts to heat, it gives you calcium oxide, oxygen, and nitrogen 4 oxide. Same reaction is experienced with magnesium nitrate, as it decomposes on heating to give you magnesium oxide, oxygen, and what? Nitrogen 4 oxide. So let's look at the group 3 elements. Now, the group 3 elements are trivalent, as they give out their 3 valence electrons and become positively charged. They are actually good conductor of electricity. Their examples include boron, aluminium, gallium, indium, thallium, and is condensed in the acronym BAGIT. Okay, good. When aluminium gives out its 3 electrons, it becomes positively charged. Now, it's important to note that aluminium reacts with steam only at 600 degrees Celsius. Okay, good. The oxides of aluminium is insoluble in water. The oxides and hydroxides of aluminium are actually amphoteric as well. Okay, they react with both acid and base to give you salt, and then that's normal salt and complex salt respectively. Okay, the reaction is given below. Now, on heating, the nitrates of aluminium readily decompose, forming brown nitrogen 4 oxide, oxygen, and what? Oxide. So if you subject aluminium trioxonitrate 5 to heat, it gives you aluminium oxide, as you can see here, oxygen, and also nitrogen 4 oxide. Now look at the reaction of amphoteric reaction of aluminium. A substance is said to be amphoteric if it reacts with both acid and base. So aluminium oxide react with tetraoxosulfur 6 acid to give you aluminium tetraoxosulfur 6, which is normal salt, and then water. The same aluminium oxide react with a base called sodium hydroxide in the presence of water to give you sodium aluminium tetrahydroxide. Okay, good. Now the reaction with hydroxide, that is aluminium hydroxide with sulfuric acid, gives you the same aluminium tetraoxosulfur 6, which is a normal salt, and then water. Then aluminum hydroxide with sodium hydroxide will give you sodium aluminium tetrahydroxide. So this is the amphoteric reaction of aluminium oxide, and these are the 3 groups that are considered in this video. In our next class, we shall be giving attention to the remaining 5 groups.